Hi guys, these are notes 8.3 for the PowerPoint 8.3, and this is on mole and particle conversions. So in the previous two, 8.1 is on molecular mass calculations, 8.2 is on mole and gram conversions, and now mole and particle conversions is all three are going to be for our first quiz. So here's my first joke of the day. I know you guys love these. So let me Okay, so the mole. I didn't get to really talk about the mole in the previous lesson, so I'm going to dive a little bit deeper here. So previously we did moles and grams, and now we're going to do moles and particles. But before we do that, let's do a quick fence post review. So this one says, how many inches are there in 4.5 miles? Now it's really nice that I gave you the conversion chart here. Oh, I got to pull up my pen. So you already know what the conversions are. You don't have to wonder, well, is this a conversion or is this my given? This is my given and these are my conversions here. All right, so start with my given, 4.5 miles. And I don't expect you to know how many feet are in a mile, and I want you to convert it into inches. I'm going to look for miles, and here I see miles. So for every 1 mile, and that's what that says, 1 mile, it kind of got cut off. There's 5,280 feet. And then the next conversion, which you guys probably know, there are 12 inches in 1 foot. But in order to get them to cancel, they have to be diagonal. So for 1 foot, it is 12 inches. So feet cancel. And so you'd put this in the calculator, 4.5 times 5,280 times 12, hit enter, and there's no numbers at the bottom. These are just 1. So what you get here is going to be your answer, and the unit is going to be in inches. All right, next one, kilometers. So we're given 3 inches as our given, so I'm going to start with there, 3 inches, and I'm going to use the conversion they gave me. So for every 1 inch, it's 2.54 centimeters. Now, they did not give me a conversion between centimeters and kilometers. So we're going to have to pull out King Henry. Do you guys remember King Henry? King Henry died unexpectedly. That looks like a P. Drinking, whoops, I ran out of room. Chocolate milk. Okay. So the big guy, which whoever is higher up, gets the 1. So K is going to get the 1. The little guy is going to get the numbers of zeros that equals to the number of jumps it takes to get to where I'm going. So I'm starting here at centi, and I need to go here to kilo. Now I know that centi has to go here in order for centi and centi to cancel. I forgot to cancel those. So centi and centi needs to cancel, which means I know it's down here. And I also have to know that centi gets the number of zeros that equals the number of jumps. So that's 1, 2, 3, 4, 5 jumps. So start with a 1 and 1, 2, 3, 4, 5 zeros, and you just put a 1 with km. So now in your calculator, and now I'm going to double check, is km what they want? And yes, kilometers is correct. So 3 times 2.54, and you can do times 1 equals, and then divide by this number here, 100,000. Your units is going to be in km, whatever you get, and that's the answer for that. So that's a quick fence post revisit. Okay, so I mentioned previously in 8.2, a mole is the SI unit for the amount of a substance. Okay, so 1 mole of any substance or anything contains 6.02 times 10 to the 23rd particles. Again, it's kind of like saying I have a dozen, but instead of that dozen equaling 12, it equals this very, very large number. And this is also called Avogadro's number. Okay, so when I say Avogadro's number, I mean 6.02 times 10 to the 23rd. I'm just going to have to say that over and over again because, yes, you are going to have to memorize that number. I can advance the slide. There we go. Okay, so just to kind of get an idea of what is a mole and how big is it, if I had a mole of softballs, which, if you don't know, is slightly larger than a baseball, it would be about the size of the Earth. So really, really, really big number. And Avogadro's number is very large, but what we are measuring is teeny tiny microscopic and even smaller than that. Because we're looking at things like atoms, molecules, formula units, so really tiny things, and we need something measurable. So we needed a size that we could actually measure something. okay? So here's the hardest part about this, is that when I say particles, I could use the word atoms, molecules, or formula units. It could be any one of these things, or I could just say particles and keep it general. Particles is the umbrella term for any one of these three things. An atom is a specific element. So like zinc is an atom, or carbon is an atom, or an atom of magnesium, okay? A molecule is a covalent compound. So H2O or CO2 or can't think of another one. Any of the covalent compounds that we have just covered, that's going to be called a molecule. That's just its name. For formula units, we use that word for ionic compounds like NaCl or anything with a metal and a nonmetal together. So again, if I have 1 mole of any of these things, I have 6.02 times 10 to the 23rd atoms, molecules, or formula units of that thing, whatever the substance is. Now, there's 2 ways to set this up. And you're going to say, Mrs. Teagues, how do I know which to use? Well, it depends on what you're given, okay? If you're given moles, then you use this setup here with moles on the bottom, see, because then they're diagonal and you can get them to cancel. Then you have that magic number at the top, 6.02 times 10 to the 23rd, and you use the word that they use, whether it's particles or molecules or atoms or formula units. If they give you particles or atoms or molecules or formula units, then that magic number goes at the bottom and 1 mole goes at the top. Okay, so either 1 mole's at the bottom or 1 mole's at the top. It depends on what they give you. All right, so let's check your understanding on this. I have 1 mole of I2. How many molecules is that? Well, I hope you are saying 6.02 times 10 to the 23rd. I have 1 mole of copper. How many atoms is that? 6.02 times 10 to the 23rd. I have 1 mole of calcium sulfate. I have 6.02 times 10 to the 23rd formula units. All right, well, how about this? Are there more atoms in a mole of zinc or a mole of carbon? Well, I hope you are saying, Mrs. Teagues, 1 mole of anything is the same as 1 mole of another thing. Yes, it's the same number of things, same number of atoms. All right, so let's try this calculation. All right, so first up, it says how many molecules of CO2 are there in 4.56 moles of CO2? Here's what's important. 4.56 is my given number, and I need to know what is the unit. I'm starting with moles here. So I'm going to start my fence post like I always do with my given, 4.56 moles. You must use a unit here or you're going to mess up your fence post. Now, because they gave me moles, then that means that 1 mole has to be at the bottom in order to get these 2 to cancel. Therefore, if I'm getting it into molecules, that's that magic number of 6.02 times 10 to the 23rd molecules. This is a long word. Oh, there's really no way to shorten that up. Okay, so now we're going to have to review how to put this in your calculator. So type in with me 4.56, and then you hit times, because these numbers are on the top. You need to multiply. Now I've put in 6.02. Now you need to find your second button, hit that, and then find that double E, EE. It might just be like a second function on top. It probably is. So find that EE and hit that button, whatever it corresponds to. And then the number or the power that it's raised to, 23. So you should have 6.02 and then an E and 23, and now hit enter. Now, hopefully you got the answer of 2.75. That it's 2.745, but I'm going to round that 4 up to a 5 times 10. It's terrible handwriting. Raised to the 24th. And if mole and mole got canceled, then my unit is molecules. Okay? If you didn't get that, you need to check your calculator. Let's try the next one, but I'm going to have to delete this to get some space. Okay. The next one says, how many moles of water is 5.87 times 10 to the 22nd molecules? Okay, now this time I'm starting with molecules, right? So I got my number and I've got my unit, and I'm going to put that down in my given. 5.87 times 10 to the 22nd molex. I'm just going to write molex. Okay, that's fine. Okay, Now, because I'm starting with molecules, that's that magic number that needs to go at the bottom, 6.02 times 10 to the 23rd molex. This is the hardest part, is remembering, molecules, that's that magic number. Molecules, atoms, formula units, or even particles could be in there. And so if that's at the bottom, then 1 mole has to be at the top. All right, so let's make sure we can get the same answer here. So you type in 5.87, find your second button, type the EE, the power it's raised to, 22, and now we need to divide because that 6.02 is at the bottom here. Divide 6.02, second, find your EE, and 23, and hit enter. And you should get 0.0975, but I'm going to round that to 98. And molecules canceled, so we're left with the unit of mole. Okay? All right, let's try 2 more. Here we have moles. We're trying to find moles in this many formula units. So formula units is that magic word to go with the magic number. So I'm going to start with my given, 3.34 times 10 to the 34th, and I'm just going to abbreviate it that way. I know that that looks inappropriate, but it's formula units, guys. Come on. Okay, so that magic number of 6.02 goes with formula units times 10 to the 23rd formula units. Yes, please write your units. Therefore, 1 mole goes at the top. Let's put it in our calculator, 3.34. Second, EE, 34, divided by, because that 6.02 is on the bottom, 6.02, second, E, 23, and you should get 5.5, and that's 48, but I'm going to round that 4 up to a 5, so 5.55 times 10 to the 10th, and formula units goes away, and my unit is mole. Okay, again, if you're not able to get that, you need to check your calculator, see what's happening there. All right, let's try another one. How many atoms are in 5 moles of carbon? All right, this is easy. I start with 5 mole. Draw my fence post. I know that 1 mole has to go at the bottom in order to get moles and moles to cancel. Then that atom is that magic number, so 6.02 times 10 to the 23rd atoms. All right, so I'm going to, in my calculator, say 5 times 6.02, second, E, 23, and your answer should be 3.01 times 10 to the 24th, and the unit is atoms. Okay? All right, if you guys have any questions, shoot me an email, let me know. I can make more resources for you if you need it, and take care, guys.